learners, welcome to Education Online program. So in our previous lesson we talked about heat and temperature. We looked at the definition of heat, where we say that heat is the transfer of energy from one point to another due to the temperature differences, and we also defined temperature as the hotness, the degree of hotness or coldness of an object. Then we went ahead and looked at the differences between heat and temperature. So today we're going to look at something known as the heat transfer. I have it as heat transfer. So if we're talking about heat transfer, what do we mean with that? Let's take an example of this. You have a glass of tea, let me say a cup of tea. So what happens to this cup of tea here? This is already hot. Let's say this is hot. So you come with some ice cubes. So from hot, now you want to make iced tea. You're going to drop some ice cubes into this liquid, into your tea. So these are ice cubes. So if you drop the ice cubes in the water, in the tea, what happens? Will the tea remain as hot as it was before? Or it is going to, the hotness is going to reduce? You see that ice cubes are actually very cold. So dropping it there, meaning that this tea, the hot tea, is going to give away its energy to the ice cubes. So when it gives its energy to the ice cubes, what happens? It is already losing the energy that it had stored. So if it has lost the energy, meaning that the hotness of this is going to reduce. So you see that there was an exchange of what? Of energy. There was a transfer. Because when you exchange that energy there, you come up with what is known as the heat transfer. So you find out that in all the objects, they do not store heat as heat, but then they store it as the energy. This is due to the fact that heat is just a process. Because when something is a process, you cannot store it in that system. So, but you can store it in the system in a very different form. So we are saying that if heat is a process, so we are going to store it. Objects store heat as what? As thermal energy. So when someone is talking about thermal energy, the person is also referring to what is known as the heat. So you see that there are majorly three types of heat transfer. So if there are three, what are those? We have types of heat transfer. We can either say, you can say types, or you can say forms, or you say ways. Those are all the same. So what are those? We have majorly three. We have the conduction, we have what is known as the convection, and then we have the radiation. So we have the conduction, a form of heat transfer. We have the convection, a form of heat transfer. And then we have what is known as the radiation. radiation, form of heat transfer. So we shall be looking at all the three forms of heat transfer one by one. We are going to start with the conduction. So if we have our conduction, where do you find the conduction form of heat transfer? Because if you look at conduction, we say that it is a form of heat transfer that is actually between solid substances. What are those solid substances? You can talk of it. We can talk of a metal rod. We can talk of wood. Those are all solid in nature. So if it is a form of heat transfer in solid, form of heat transfer in solids, or we can say solid substances. So if it is solid substances, we mean also the direct, because if you look at conduction, it has this letter D here. This letter D here means direct. So if it stands for direct, that means that for this form of heat transfer to occur in those the substance we are talking about, that means they should be in direct contact with each other. So if I have this, let me say I have this, and then I have this. I want to transfer the heat energy from this object to this one. I don't put them just far away from each or near, but then I make them come into direct contact with each other like this. So when they're in direct contact, that means that the form of heat transfer we are going to have there is known as the conduction. So how is this conduction type of heat transfer very possible in between the solids? We are saying that let's have a solid object here. Solid object is being made of tiny particles. So these tiny particles are known as the electrons. So in the solid particles, what happens with these tiny particles? These tiny particles are very closely attached to each other. Just like what I've drawn here, we can see that the particles don't have even enough space for them to move from one point to another. So you see that they are compact. This one is solid like this because the particles in it, the particles that is making up this, they are very closely together. They are compact together. That's why you see that it has this shape. So if it is compact like this, how will the heat actually be transferred from one point to another? Yet we are saying that here, the particles do not have space for free movement. If you don't have space for free movement, then how is the heat transfer possible? You see that when there is a point, when one part of this object here has a higher temperature, what happens is that these particles, electrons, they're going to vibrate. Instead of moving from one point to another, here they will be causing vibration in between them. So this vibration will cause, assuming this side here has a high temperature, so they will be vibrating. As this one is vibrating, it is going to lose its energy to the next electrons that are surrounding it. So as those ones also keep on vibrating, they also lose the energy they have to the next electrons. So the next electrons, what they do is they will gain the energy that has been lost by by the electron that was surrounding them. So you'll see that there will be continuous transfer of this heat because of that vibration. The more the vibration occurs there, the more this heat is going to move from this point up to the point where the heat was not, where the temperature was actually low. So that's why you see that when you put any object, maybe you take a metallic rod, try to fix it in the, put it in on fire. So as the downer tip that is touching the fire is warming up, remember your hand is in direct contact with the metal. So you think that the part you're holding is not actually, does not touch the fire, but then you also feel the metal around your hand to become warm. Then from warm, as you keep it on the fire, what happens is it's going to be very hot, that even touching will be a problem. This is because the electrons around, the electrons that were next to the place touching the fire, kept on vibrating and distributing their energy from themselves to the neighboring electrons. So these electrons, the neighboring electrons, also transfers it ahead. So they keep on transferring. That's why you see that at this point here, the energy felt down here. You also feel the same on this part, or on the part that has not touched the fire. So when we are talking about conduction, we need the direct contact. So there must be a direct contact. Direct contact of the systems. Should have direct contact of the systems in place. So now that is how the conduction actually works, and that is how the heat is transferred by the conduction form of heat transfer. So let's look at the second one. We are talking about convection. So what is this convection type of heat transfer? We say that with the convection, it is the movement of heat by actual motion of the particles of any of a gas or liquid. Because when we are dealing with convection, we are dealing with fluids. And when I talk about fluids, fluid does not only mean the liquids, but also the gases, So if we have convection as the mode of heat transfer in the gases or the liquid, how is that possible? How can liquid transfer its heat? So let's see this. We are saying that this is a form of heat transfer. Due to the movement of the actual particles. So where is this element of movement coming from? Convection has a V. So the V is showing us the movement of the particles. Just like in conduction, we were taking the D. Just as a reminder, when you're talking about the conduction, the D we are saying is standing for direct contact. So now look at convection. It has V. The V is in the V in movement. So which movement are we talking about here? We are talking about the movement of the particles in the liquids or the gases, because we say that liquids and gases are also made out of particles. But how is the nature of these particles in liquids and the gases? Let me take a container like this. The container has got water. So you see that these parts here, the particles in water, are almost like that. So these ones we are meaning are the particles, and then we have it is the in water, or we can talk about any other liquid. So the particles in liquids and gases are not closely compact together as the particles in solids. That's one of the reasons. You see that solids have got shape, but then liquids and gases do not have the shape. So you see that if these particles are just are not closely packed together, they have free space. That means that there is space for movement. They are free to move from one point to another. There you see that's the element of the V in convection. So if they can move from one point to another, what happens? You see that when one part of the liquid or the gas is warm, they're going to move, the molecules at that particular point will be moving randomly, and as they are moving randomly, they will be colliding with other molecules in the cooler side of the liquid. So as they collide with those molecules in the cooler side of the liquid, you see that those molecules also do not just remain stationary or just that vibrating in one place. They have the ability to still move freely. So as they move, there will be, if this part was warm, you see that this molecule has a tendency to move up to this point, and then it meets this molecule on this point, then loses the energy to that molecule. So this molecule does not also remain there. It keeps on rotating. As it is moving, it keeps on its way. They keep on colliding with each other. Not only with each other, but also with the surface of the container. So that random motion there makes them to take this temperature, to transfer the temperature from a point where it is high to a point where it is low. This is why you see that water is in position to boil. How is that possible? Because our water, when you put on fire, since it is liquid, it has these random particles that are in random motion. So you see that this is your liquid. You have your fireplace. This is the fire. So what happens is you're going to, when you bring your saucepan right here, you see that it starts warming from this point. Down here will always be very warm, because you see that here the saucepan is in direct contact with the fire. So the liquid in the bottom of the saucepan will become warm. But then what of the other one on top? How is it possible that these ones, even though this part here is not touching the fire, it still warms up? Because the molecules here, after heating up, what happens is that their kinetic energy increases. And when a kinetic energy of a substance increases, meaning that the molecules can move faster. Now here they start moving randomly and faster up to this point, and you find out that this cool one here, when they absorb the energy, they also continue with their random motion, moving downwards. So that continuous movement allows the transfer of the heat from the bottom of the saucepan to the top. That's why you see that water, when you put on fire, is in position to boil. Because if it was not for this motion, for the transfer of the heat, only the water at the bottom here will be warming, but then on top the liquid will remain cold. So that is in case that the molecules actually don't move. But in case they are also just vibrating, there will still be heat transfer, because their vibration caused that the movement, the transfer of that heat from one point to another. So you find this mostly the convection, you find it in the liquids and the gases. So we have the last form of heat transfer, which is the radiation. With the radiation, let's take a look at yourself. Probably as you're moving, the sun is very hot, but then you feel that heat. Why do you say that the sun is actually hot? Because you feel the heat from the sun. But did you actually touch the sun? No. Did the sun touch you? No. But still you feel the effect of the sun because of the radiation form of heat transfer. With the radiation form of heat transfer, it does not require a medium of transfer, and also it does not require direct contact. For it, it can transfer the heat in vacuum, or you can say in space. So you see that's why when it is cold, someone sits and then sits next to the fireplace and then gets the warmth from the fire. Why? Because it is observing the radiation. You get the heat from the space. It is in position to come from that point and then reach you where you are. It is not for it. It's not like the conduction and convection, where they require medium for the transfer. So you see that with the radiation also, there is no mass exchange. So this radiation does not also require mass exchange. So you see that they have their similarities, where they are all the types of heat transfer. All these, it is more like a method that heat can be transferred from one point to another. But then they also have got their differences. Why do they have their differences? We shall see that in our next lesson. So thank you very much for attending this lesson. We shall still meet again in the next lesson.